This section starts off a chapter on area, which is heavy on formulas. Hopefully many of you have seen these first few though. In grade school, they often start off introducing rectangles as having a length and a width like the picture here. Usually by middle school, they have started switching over to the new vocabulary. But if you haven't switched over yet, now is the time. Instead of calling the sides length and width, you need to get used to calling them base and height. This is the way grown-up mathematicians refer to the sides of a rectangle. It is more consistent with other shapes, as you will see later on in this presentation. This is a formula you should already know, especially since we did it in section 1.8. But the area of a rectangle is base times height. Some of you may know it instead as length times width, but you've graduated now. Time to use the real names. Hopefully this is review. We need it fresh in your mind as we do the next one. A parallelogram is next on the docket. It also has a base and a height, just like a rectangle. But this is not the height. The height is always perpendicular to the base, so you need to draw in one of these. This is a proper height. This isn't the only height. All of these are also heights, and any would work in the formula. However, where I originally drew in the height, the black one, is particularly useful and by far the most popular as it forms a convenient right triangle. And by now you should be very adept at dealing with many different kinds of right triangles. So there are a lot of possible heights here. And similarly, you are not locked into which side is the base. Just like most things in geometry, rotating something doesn't matter. Looking at it from a different direction doesn't matter. So we get to choose which side is our base. If we want this to be our base, then gosh darn it, we can have this side as our base. Students often don't like that, but the base doesn't have to be down. However, once you have decided that this side is going to be your base, then this is one of the heights for that base. It isn't the only one, as I did on the last slide, but you have to use one of these in the formula for your height. Now to some quick semantics. This is going back some, but at the very beginning of this course we had line segments. And when we did line segments, there was this portion where we went over the difference between line segment AB and distance AB. Do you remember that stuff? The shape can be congruent, not equal. It's a physical thing. The distance can be equal, not congruent. It's a concept. That distinction is very similar to the difference between an altitude and a height. We are now dealing with parallelograms. We will often be drawing in that red altitude. Or is it height? The words are often intermingled and swapped seemingly randomly, but here is the actual difference. The altitude is the actual line segment itself. It's a physical thing. The height is the length of that altitude. It's a distance. It's a concept and might have units. Very similar to our line segment versus distance discussion from before. It's a tiny difference, but if you wanted to know the difference between the two, that is what it is. Now let's get to the formula for the area of a parallelogram. Let's look at this lovely parallelogram below. It hasn't hurt anybody. It is actually a very nice parallelogram. But we're going to dissect him anyway. Let's cut him right here. Sorry, parallelogram. We have now cut our parallelogram. I did that for a reason. Once this parallelogram has been cut like this, what happens if I move that piece over and attach it there? My parallelogram has transformed into a rectangle. Remember, I started with this shape, and I ended up with this shape. No area was lost or gained. This parallelogram and rectangle both have the same area. What are we getting to with all of this? The formula is the same as the rectangle one. You don't have to memorize anything new. Yay! I've mentioned this a few times trying to drill this into you, but when you are faced with problems like this, make sure you use the right height. 13 is not the height here. The 12 is. You need to use the 12 in the formula. The formula isn't hard, but if someone is going to make a mistake, it is often that they have used the wrong length for the height. The last one is the area of the triangle formula. This is also review. We also did this in section 1.8. Plus, most of you have done this formula for many years. So I won't go into too much detail about it, but there are two quick things to mention. First, when you have a triangle, just like a parallelogram, make sure you are using the correct height. For some reason, students usually don't mix this up as much as with parallelograms. The second thing to quickly note about triangles is, just like parallelograms, you have the freedom to decide which side will be your base. If you decide to do the boring simple choice, then you can choose this as your base. If you do that, then this is the corresponding height you would use. But that is not your only option. You could be a rebel and forego the obvious bottom segment and decide that you wanted this one to be your base. That's perfectly fine. If you do, then this becomes your corresponding height. That only covers two possible choices. Obviously, we have a third side too, and you can absolutely choose that to be your base if you like. If you do, then this green segment becomes its corresponding height. Those are the two things to be aware of with triangles. Otherwise, we are just using these three formulas that you have known probably for a while.